Welcome to the lesson on evaluating and simplifying algebraic expressions. And as with most lessons, we have to start with some vocabulary. And the first one we're going to talk about is a numerical expression. A numerical expression is a phrase that consists of numbers, operations, and grouping symbols. It's important to note what I didn't say. I didn't say an equal sign. So expressions are like a phrase or a part of a sentence. They don't have a conclusion. They're just a sentence fragment. So a numerical expression is a phrase that consists of numbers, operations, and grouping symbols. Let's write that down. Some of the numerical expressions that we've seen are powers, and we're going to dig in and review powers a little bit. A power is an expression formed by a repeated multiplication of the same factor. So I'll give you a minute to write that down, but it's an expression formed by a repeated multiplication of the same factor. Now remember, you can pause the video to write down these definitions. So let's look at our power. This whole thing right here is called the power, and it's made up of two important parts. The first part is the exponent. That is this number right here, the little green 3. And there's your definition of the exponent. It represents the number of times that the base is used as a factor. So we will just go ahead and write down the definition for the base, and that is simply it is a factor. A factor, remember, is a building block of a product. And so this base number here is considered your factor, the thing that is being multiplied, in this case 3 times. This is important to notice down here. And it says when you see a number that has an exponent of 1, we don't really usually write the 1. It's just assumed to be there. So in this example, if you had 8 to the first power, you would simply write it as 8. In fact, any whole number like 4 to the first power, we would just write as 4. Okay, sorry it's sort of writing over itself, but that'll work itself out eventually. All right, so let's look at how we can actually evaluate powers. We'll look at example 1 down here. If we had 13 with an exponent of 2, what it really means is we are taking that base number 13 and multiplying it by itself 2 times. This is the important part that I want to see, that you know that 13 to the second power, or 13 squared, is really representing 13 times 13. If you go ahead and do it on your calculator, that is icing on the cake, but this is the part I want to see, especially for this section. 2 to the 4th power, quite straightforward. It's 2 times itself 4 times. So 2 times 2 times 2 times 2 turns out to be 16 on your calculator or wherever when you do it. These next two are the important ones. I'm going to erase this, get it out of our way. And that is because this number here is negative 5 to the 4th power. And this number here is negative 5 to the 4th power. I said them differently, didn't I? What you need to realize is when you have parentheses with an exponent outside of the parentheses, it's telling you that that exponent is acting on the parentheses in its entirety. So this power is going to take negative 5 times itself 4 times. This one over here is going to take 5 times itself 4 times and then make it negative. So I'll write down and show you what I'm talking about. For C, written out, you have negative 5 times negative 5 times negative 5 times negative 5. And when you do that, you have 2 sets of 2 negatives. And so your answer will end up being positive. Negative times a negative is a positive, times another negative is a negative, and then it turns back positive. So when you have an even number of negative signs, your answer will be positive. So this is a positive 625 for C. Now D, on the other hand, starts off with that negative just hanging out in front, and then I take 5 times itself 4 times. If you need to rewind this and listen again just to get this, it's really an important lesson, and kids sometimes get problems wrong because they don't understand this intuitively. So for this problem, it's 5 times 5 times 5 times 5, which is 625, but now this negative sign is going to go out front. So you have 2 problems that look similar but give you different answers. And believe me, if we were talking money, you would not think that's the same number. Okay, so now we're going to change topics a little bit, and we're going to start talking about the order of operations. It's very important to remember these so that we are all talking about or all getting the same answer when we're working on algebra problems. The order of operations starts with your first step being working on all the operations that involve grouping symbols. So let's write that down. First, you need to work on operations that involve, let's say, grouping symbols. Okay? So what do I mean by grouping symbols? Those are the parentheses that we're used to seeing. They can be brackets, and one we hardly ever think of is the division bar. That is also a grouping symbol. What it does is it groups your numerator separate from your denominator. And that's usually why we work at the top or the bottom, and very rarely do we overlap that. The second step that we deal with in the order of operations is the powers. So second, we look for any powers in our expression, and we would evaluate them like we just did in the examples on the previous slides. So second comes powers. Then third comes, and this one people kind of screw up, comes multiplication or division. Or division. They are on the same level. Okay? You would decide which one you do first by reading your problem from left to right, just like you read a book. So you look at your expression from left to right, and you say which one comes first, multiplication or division. Sometimes you do division before you're going to do multiplication. The same applies to the fourth step, which is, I'm trying to move that, I'll have to move it later, addition or subtraction. It is the same idea. That is also from left to right. And again, it's how you read the expression. All right, just like you would read a textbook, whichever one comes first, you would do first. So now we are getting into a little bit more foundation for algebra, so we can move on quickly. And we need to define what a variable is, and I'm sure you all know it already, but it is a letter that represents one or more numbers. A letter, used to represent one or more numbers, depending how many variables you have. And so when you were a kid and you were working in class, you probably remember that you would see a box in your problem, and they would say box plus 2 equals 10. Well, they were getting you ready for the idea of the variable, because that box is something we don't know. It's an unknown. But now instead of writing it with the box, we would write x plus 2 equals 10 and solve it, or do the mental math. So we've been doing that for quite a long while. So an algebraic expression then is different from a numerical expression. I defined that in the beginning. But an algebraic expression is an expression involving variables. Okay? So an example of an algebraic expression would be, say, x plus 2, like we just did, or it could be a plus b, or maybe 4 divided by c. Something like that. Notice again there's no equal signs, we're only talking about an expression. So if we needed to evaluate an expression, and again this is probably going to float, but I'll move it down later, simply when they asked you to evaluate an expression, they want you to substitute a number in for each variable and then simplify. So substitute a number in for each variable, they'll tell you what the numbers are, and then simplify. That is what they are asking for when they ask you to evaluate. Sorry, and that moves down then. I hope I spelled it right. Substitute a number in for each variable and then simplify. There it is. Here's an example where they ask you to evaluate this expression, and all you would do there then is wherever it says x is a -3, you would substitute that in. So please show your work and you rewrite it with the substitution step in there. And be careful and notice that I used parentheses around my -3. It's telling you x is being squared and x is a -3. So -3 in its entirety needs to be repeatedly multiplied. Alright, then go ahead and fill all that in. and do the math to figure it out. So according to the order of operations, I need to do any grouping symbols. I have parentheses, but they're not grouping symbols here. They're just simply kind of bracketing in that -3. So I would next do my exponents and rewrite the steps for me, please. So -3 squared turns out to be -3 times the -3, which is a +9. And then you could rewrite this entire thing. And I have a bunch of addition and subtraction, but I need to move from left to right. So 9 times that -4 is going to be a -36. So I did that first. And then I'm going to look at my -6 right here and my -3, which turns out to be, when you multiply it, a +18 and then +11. So this right here, when you do it on your calculator, would be a -18 plus 11, and then when you add those together, you're going to finally end up with a -7. I would like you to try example 3 to see if you can write expressions and then find your profit after you substitute in certain numbers. So go ahead and try example 3. So this example says you're selling homemade candles at a craft fair for $3 each, but you've spent $120 to rent the booth and buy the materials for the candles. So they're talking about your profit. Well, your profit comes from the $3 times the number of candles you sold. But no matter what that number is, you're going to have to subtract 120 from it because that's what you've spent. I'm not going to put an equal sign in because this is only an expression. But I can move on and find out what my profit would be if I sold 75 candles. I'm going to substitute in for C that 75. Oops. And then go ahead and subtract that. So 3 times 75 gives you 225. And from that you would subtract 120, which is going to leave you with $105 of profit. Not bad. So go ahead and do these guided practice problems, and then, well, pause the video now, and then come back and we'll check and see if they're right. All right, well, at the bottom, I've written the answers out to problems 1 through 6. So go ahead and look at those. The answer number 5 is right here. It's kind of hard to see. It's a 20. Please make sure you're showing your substitution steps. That's what I'm looking for. Make sure you're watching your signs. And number 7, you would take that example 3, and instead of C being 75, you would now put 135 in and get your answer that way. If you wanted to write an example for an algebraic expression, the key is to have a variable in it and some operation, it doesn't matter what, and maybe another number. You could also just have simply a variable like y. That would also be considered an algebraic expression. Base, remember, is the large number. It is the factor of a power, and so you could put 2 in there to show what that is. So 8 would be your base number. Your exponent would be 2 in that case. Perhaps I should have wrote it off to the side. And then a numerical expression is different than an algebraic in that there would be no variables. They would just be numbers like x. Look at me, and then I do it. Like, trying to delete that. I guess I'll do that. Like 2 plus 4. That would be doing it for you right there. There's your numerical expression. This section of the lesson is actually super important because this is how we communicate with each other all year long. So we take our expressions and we start using words like terms and coefficients and constants. And when I'm saying words like that, you really need to understand what I'm talking about. So let's go through, and up here we're going to write in some definitions and take our time doing it. So the first thing we need to identify is the word term. And when you're talking about expressions, the terms are the parts that are being added together. Sorry, trying to get this. So let me show you an example of what I mean. And it's always, I like to think of it as the chunks. So if I had an example like, and I'm making this up, 2x squared plus 4x plus, well, let me say minus 1, just to make it interesting. So I will say minus 1. the terms here are the numbers 2x squared, 4x, and -1, because those are the numbers that are the chunks that are to the sides of the plus sign. And so because this right here is really could be KCO'd and become plus a -1, the definition of subtraction, we have to say that -1 is a term by itself. So if you wanted to write that down, maybe we should, and write down that the terms of this expression are 2x squared, and put a comma, 4x, and then -1. So those are the terms. So moving on, then we're going to talk about a variable term, and that simply is the term with the variable part. So 2x squared and 4x are variable terms. I'm not going to go into that too much. You don't even have to write it down. But a constant term, now that's more important. A constant term is the term with no variable. Now you don't always have one, but in this case we do. We have the -1. So in this example, -1 coming. Oh geez, sorry. Let me move this back. All right, go back to the pen. -1 is your constant term. It's constant. It's not varying. So maybe that'll help it make sense to you. And then finally, we have the word coefficient. Let me capitalize. C-O-E-F-F-I-C-I-E-N-T. And that is the number before the letter. We're going to think of it like that. The number before, really, the variable, but you can go ahead and think of it as the number before the letter. So which numbers in this expression would be the coefficients? Well, we have a letter right here, so the number before it would be 2, and we have a letter or variable right here, and the number before that would be 4. So we only have 2 coefficients in this case. That would be 2 and 4. -1 is not a coefficient because there is no variable after it. It's a constant number. I moved on without you, and I wrote down the definition of simplifying an expression. So when you are given directions that say simplify the expression, you can't always find an answer. All you are being asked to do is take away all the grouping symbols as best you can. That might be a distributive property problem. But more importantly, make sure all your like terms are combined. That is like the big deal about simplifying an expression. Just make sure everything is as simple as it can be. Everything is put together like terms with the same variable parts, or something would be distributed if it could be. Combining like terms is a nice little task that you should be used to, and when we are asking you to combine like terms, that means you need to add or subtract terms with the same variable part. So there's that definition for you right there. Combining like terms means you're going to add or subtract terms with the same variable part, and we will work with some practice problems on that. So here's the examples where we're going to combine like terms, but before we do, you might want to read how to avoid some errors over here. Just because your terms might have the same letter does not mean they have the same variable part. Notice here at 3p squared, that means I have 2 p's being repeatedly multiplied. That's not the same as having 1p. So the exponents matter. If the letter is the same and the exponents are the same, then you can combine them. But check for that when you're working. All right, so let's look at example A. I have 8x plus 3x. Your first question to ask yourself is, are those like terms? Well, do they have the same variable part? They're both x's. They're to the same power. So yes, we can combine those because they have the same variable part. So 8 plus 3, you take your coefficients first. Remember, those are your numbers before your letters. You take the 8 and add 3 to it, giving you 11. And you put down your exponent again, your variable again. So 8x plus 3x is 11x. In part B, not everything is a like term. You only have 2 terms that could be combined, and that is the ones with the p squareds. This is all by itself, and it's just going to hang out there at the end, but I'm going to combine 5p squared minus 2p squared. 5 minus 2 gives you the 3, and you put your variable part back down, 3p squared, and we can't combine it with that other p so it just stays there in the expression. Letter C is an example of when we would have to distribute in order to simplify this. So the first thing you need to do off the bat is distribute, and remember that's taking that number outside and multiplying it to each term inside the parenthesis. So 3 times y gives you 3y, and then 3 times that 2 gives you 6. And then moving on, and watch out for that negative, you have negative 4 times y, that's negative 4y, and you have a negative 4 times a negative 7, that's a positive 28. So now you look at your expression and walk through and say, what can I combine? Well, I have a 3y and I have a negative 4y there. So I can put those together, and when I do, I get a negative y or a negative 1y, whichever one you want to use. And then I have a 6 for a constant number and another constant of 28. And when you add those together, you end up with 34. And you have this expression as simplified as possible. You can't put those two things together, so you are done. The last example, you have 2x minus 3y minus 9x plus y. So I have two sets of like terms. I have variables of x and I have variables of y that I can put together. So 2x plus a negative 9x or 2x minus 9x gives you a negative 7x. And negative 3y plus, and be careful, remember there's really a 1 right there, and so you have negative 3 plus 1, and that is negative 2y. Sorry if those look the same, this would be an x. Alright, your turn. Your guided practice problems are below, so go ahead and work on those, and then hit the button, and we will check our answers together. Alright, and here are your answers. There could be mistakes, you let me know if there are, but those are your answers, so go ahead and pause the video and check them. And remember, you can always go back and watch the video if you were confused about something. This last side is pretty important. It's telling you how to put things in your calculator correctly so that you make sure you get the right result. Number one, when using a calculator, you still need to use your brain, okay? Have an idea of what the answer should be before you even put it in your calculator. But go ahead and do these problems. I can't recommend it enough. If you have a scientific calculator like a TI-30, this tells you the keystrokes you would use to get the right answer out of something like this. If you had a graphing calculator, these are the strokes you would use or the buttons you would push in order to get the right answer. So go through and try A, B, C, and D and make sure that you're getting these answers out of your calculator. And then you can go ahead and do the practice problems and maybe compare your answers with a neighbor and make sure that you're getting the same thing. Again, people like this, or problems like this, if you put those in wrong, you're going to get the wrong answer. And it happens all the time, trust me, that I see kids not being able to use their calculator correctly. Well, thanks for watching the video. Remember, you can watch it again if you want to, but good luck and let me know if you have questions.